to bioprocess lab first. And then instrumentation lab.
Bioreactor. Headplate. pH probe. Controller. Bioreactor with motor and connections with controller. Peristaltic pump.
Gas chromatography.
ये भी एक हिस्सा पार्ट ऑफ, जैसे जब आपने फर्मेंटेशन किया तो उस फर्मेंटेशन में क्या प्रोड्यूस हो रहा है तो वो आप एनालाइज करोगे। आंखों से देख के तो एनालाइज कर नहीं सकते, आपको कोई एनालिटिकल इंस्ट्रूमेंट चाहिए। तो एनालिटिकल इंस्ट्रूमेंट में एक फ्लोरीमीटर भी हो गया,
Fluorescence spectrophotometer.
एक हमारा होता है जीसी। जीसी इज गैस क्रोमेटोग्राफी। गैस क्रोमेटोग्राफी, अगर क्रोमेटोग्राफी के बारे में अगर आपको पता हो तो क्रोमेटोग्राफी इज सिंपल आ सेपरेशन टेक्निक, ठीक है। लिक्विड क्रोमेटोग्राफी जिसके अंदर हम लिक्विड को यूज़ करते हैं फॉर सेपरेटिंग एनी एनालाइट। मतलब जब ऑर्गेनिज्म ग्रो हो रहा है तो ब्रॉथ के अंदर बहुत सारे कंपाउंड्स होंगे, या तो प्रोटीन्स होंगे या लिपिड्स होंगे, तो उसको सेपरेट करने के लिए हमें क्रोमेटोग्राफी की ज़रूरत पड़ती है, ठीक है।
Hisi.
ये लैमिनार है जिसमें हम ये सेंट्रीफ्यूज है। सेंट्रीफ्यूज इज यूज्ड फॉर सेपरेटिंग सेल्स, और मतलब अकॉर्डिंग टू द मॉलिक्यूलर वेट सेपरेट करने के काम।
Shaker. Basic Hall. Instrumentation is the use of measuring instruments for observation, monitoring, or control.
This lab is the downstream processing. After fermentation, you have to come here and you have to analyze what is happening to your sample. There are different methods by which you can determine what is happening. In chromatography, we have two phases. One is known as the mobile phase, one is the stationary phase. Mobile phase is your mobile carrier, which will carries your analyte to your stationary phase. And in column, you have the stationary phase, which is the static. And your analyte will interact with your stationary phase. So, in presence of mobile phase and stationary phase, there will be the distribution of your analyte between your mobile phase and stationary phase. And this will depend on your distribution coefficient of your analyte.
HPLC. High Performance Liquid Chromatography.
ये solvent bottles है हमारी. At a one time we can use 4 solvents. This is the quaternary pump, means we have 4 pumps. One pump will suck solvent from one bottle, another will suck from the another bottle. Okay. This is the mix. We are operating 90% of water, 10% of ethanol. It will mix here. So this is the mixer. After mixing the solvent, it will go to your column. So we can put our column here. And this is the column oven. So you can set the temperature of your column. At what temperature you want to separate. Then whatever is separating out will go to the detector. So here we have two detectors, UV visual detector and refractive index detector. So after separating your analyte will go to the detector and it will detect and give you the chromatograph. This is the software. And this is the auto sampler. You can put your sample here. Like you have the 100 sample, you can give the 100 sample at a time. Give the program, it will do the analysis for each sample one by one.
Agilent company guys.
This is from the Agilent company. If you don't have the auto sampler, you have to inject manually. So here you have to sit here, and after one analysis complete, you have to inject your sample, then wait, then second, then third. But sampler, you just give the program, put your sample and go. Yes, analysis will automatically done.
हर sample में खुद से ले लेंगे.
So here, this is for the sample. How much sample, amount of the sample you want to inject. Suppose I want to inject 10 microliter, 30 microliter, 20 microliter, I use it here. Merit detector where we can select the wavelength, and RIV detector we can select the RIV detector. and we will get the chromatogram and we can analyze. So suppose you want to analyze whether your ethanol is formed or not formed. So what will happen at time 0? Your ethanol will be, there will be no peak because the ethanol is not present. But after 10 minutes or 30 minutes, if your ethanol production is increases, what will happen? It will give some peak. Okay. After 1 hour, suppose only 10 micromolar protein is ethanol is formed. After 1 hour, it is 100 micromolar. So what will happen? The height of your peak will be increases. So by calculating the area under curve, you can calculate how much ethanol is producing. And you can also check whether it is ethanol or any other product. How you can check them? It is ethanol or other is it ethanol? You can run the standard ethanol. Okay, you took the ethanol, inject and pass out through the column. It will have its own retention time, like it is looking at the 10 minutes. Okay, so at 10 minutes, and you know the concentration also, like my concentration is 100 millimolar. You are injecting 100 millimolar ethanol and you are getting this much of peak height. Okay, at 10 minutes, retention time is 10 minutes. And in your fermentation product, whatever you have injected, you are also getting peak at the retention 10 minutes, means retention time is the same. So there are the more probability that you have the ethanol, but the peak height is half. Means if you are in a standard, you have the 100 millimolar ethanol and peak height was this much. Now the peak height is the half, means you have the 50 micromolar concentration. Okay, so if you run the standard of different concentration and from the standard plot, you can know the concentration of your unknown also. Okay, so it can be used for the qualitative and quantitative purposes. It is used for the protein suppression, and protein can degrade at high temperature. That's why it is put in the cold chamber, 40 degrees Celsius. Principle are same, but here heat size is big. So we have to apply less pressure, and the column length will be more. This is the This is the column line. Here we use the glass column. Here it is only the quantitative analysis. You have to inject very less amount of your sample. But if you have 100 ml of your sample and you want to separate them, then you have to use this one, not this. Okay. First you know that okay, my ethanol is forming, and you have the large scale and you want to separate them. You can use this and you can separate. So large scale production, this will be used. For quantitative analysis, this is used. Okay?
CHNS analyzer.
Suppose आपका इथेनॉल बनना है, इथेनॉल का एक फॉर्मूला होगा. व्हाट इज द फॉर्मूला ऑफ इथेनॉल? C2H5OH. ठीक है, इसमें अपना ऑक्सीजन का परसेंटेज होगा, कार्बन का होगा, हाइड्रोजन का होगा. सो इफ वी वांट टू एनालाइज हाउ मच कार्बन यू हैव, कार्बन, नाइट्रोजन है, सल्फर एंड नाइट्रोजन, सल्फर, कार्बन एंड हाइड्रोजन. So percentage of carbon, hydrogen, nitrogen, sulfur can be determined by using this CHNS. ठीक है. Here we can use both solid and liquid samples. Two tubes, one is known as the combustion tube, and another is known as the reduction tube. What will happen? You have to pack your sample in the aluminum foil. Like solid sample, you can pack in the aluminum foil. You will put from here. It is the auto sampler. You can give 80 samples at a time. One by one, it will analyze. It will go into the combustion tube. When it will go into the combustion tube, its combustion will be happening. It will completely burn out. So your sample have carbon, hydrogen, nitrogen and sulfur. Then it will burn. Okay? So after burning, this compound will form. How many gases will form? Carbon dioxide, sulfur dioxide, nitrogen gas and oxide of nitrogen, and hydrogen का water will form. Okay? And you have to remove the oxygen. So how you can remove the oxygen? There are the another tube which is known as the reduction tube, in which we have the filled with the copper. So copper will absorb all the oxygen, which is used in the burning of your sample, and it also absorbs the oxygen from the oxide of nitrogen. So now after passing this combustion tube, you have only 4 gases. One is nitrogen, water, carbon dioxide and sulfur dioxide. Here also again the chromatography will play the role. Here 3 column we have. which will absorb, one will absorb hydrogen gas, water, one will absorb carbon dioxide, one will absorb the sulfur dioxide. Okay. So after passing these column, all three gases will absorb, only nitrogen will remain. So nitrogen, without observing, it will go to the detector. Here we have the thermal conductivity detector. When there was no gas, only helium is passing. The helium has the different conductivity. It will detect by the detector. But when you have the nitrogen with helium, the conductivity will change. And this change will detect by the detector and give one peak. And it will calculate on the peak height, it will calculate the percentage of your nitrogen. Now, three gases are in your column. Now, how you can separate them?
Gas chromatography.
You can, this is a gas chromatography only, but you can increase the temperature. It will go to the detector and detect by the detector on the basis of conductivity, and it will give the peak. So on the basis of peak, you can identify how much carbon is have, carbon, hydrogen, and sulfur can be identified. So why we use gas chromatography? If we have already the liquid chromatography and it is also generating your analyte, why we need the gas chromatography? And what is the difference, basic difference between gas and liquid chromatography?
Mobile phases.
Mobile phases. So there mobile phase is liquid, here mobile phase is gas. And what is the difference, basic difference between gas and liquid chromatography?
Mobile phases.
Mobile phase. So there mobile phase is liquid, here mobile phase is gas. Two samples, one is volatile, one is non-volatile.
Yes, sir.
So for volatile sample, which technique we will use?
Hplc for volatile samples.
It directly in the gaseous form will go to the column. It will separate like HPLC. Here also it will separate and go to the detector and it will detect it. Okay? Here column is this one. The diameter of column is very less and length is more. And from the column your carrier gas will go out, and this is the injector where your this is the auto sampler. Here you will put your sample. After injecting, this needle will suck your sample and inject here. Here your temperature, you have to set the temperature of your, depending on the boiling point of your sample. Suppose your boiling point is 100 degrees Celsius, so you have to separate 110 or 120. So at 120 degrees Celsius, your all sample will be vaporized in the and converted into the gaseous form. Then it will flow from your column. There it will be separate. Then it will go to the detector. So here this is the out point and this is the end point. Here we have the detector, which is the flame ionization detector. It will go to the detector where it will burn out and detect.
Okay.
The main difference is the mobile phase, and it is for volatile sample.
Downstream
that is for the
processing.
non-volatile sample. And other principle is same.
आप बताइए क्या है?
ये है बच्चे GCMS.
Gas chromatography mass spectrometry.
ठीक है, आप किसी कंपाउंड का मास भी पता कर सकते हो ना M/Z रेशियो से. ठीक है, ये सोनिकेटर है. ठीक है, इसमें आप अपने सेल रखते हो. ठीक है, सेल रखते हो और डिस्क्रिप्ट कर सकते हो. जैसे आप मान लो इक्वल ये कल्चर लिया. ठीक है, तो इसमें अपने नोजल लगा के एक ऐसे नहीं रखते हम लोग. इसमें क्या करते हैं, बीकर के अंदर रख के उसको सेट करते हैं और इस नोजल को अंदर डालते हैं और ऑन करते हैं. ऐसी आवाज़ करता है, ऐसे करके आवाज़ करता है
ब्रेकडाउन.
और बर्स्ट कर देता है सेल्स को. बहुत अजीब सी साउंड करता है. इसको ना हमेशा बंद करके करते हैं.
ये खराब पड़ा है, पहले इतना बड़ा होता है. ये खराब हो गया, अभी मैं दिखाता हूँ.
आ जाओ, ये मास स्पेक्ट्रोमीटर वो भी था, ये खराब हो गया. मतलब ये पुराने टाइम का था. है कैसे
स्पेक्ट्रोस्कोप.
मास स्पेक्ट्रो.
ठीक है, तो जब इसके साथ एलसी के साथ हम मास लगा देंगे तो इट विल कॉल्ड द एलसीएमएस. CMS, LCMS. So this is the LCMS setup. अभी ये इंस्टॉल हो रहा है, कंप्लीटली इंस्टॉल नहीं हुआ है. प्रिंसिपल सेम है. यहाँ से तुम्हारा ये कॉलम ओवन था जो दिखाया था. कॉलम ओवन से जो भी एनालाइट होगा सेपरेट होके मास में जाएगा. देयर यू कैन डिटेक्ट द मास ऑफ योर एनालाइट एंड आइडेंटिफाई योर. ठीक है, तो दिस इज द सेटअप फॉर द LCMS.
So, this was one of the memorable day. It was fun learning new techniques, and you will be shocked to know that these machines worth lakhs of rupees. So, we are heading towards the exit after a jaunt and uncountable photographies.